we're going to quickly review Lesson 4.1 because this should be review for all of you from last year and you've all used it a lot. If you need more help on it, then you can ask me in class or you can review the book. It's page 176. So very quickly, when we're talking about the coordinate plane, we have an x-axis and a y-axis. And when you go to plot points on this plane, x is always your first coordinate, y is always your second coordinate. So whatever's here, you always go over or back first, and then for y, up or down to graph these. And we'll do a couple in the work tomorrow just to make sure you remember how to do that. The biggest thing is that I know is new to some of you, or you just might have forgotten, are the quadrants. There are 4 quadrants that this is split up into. You always start in quadrant 1, which is the positive positive. It's kind of where you first learned how to graph. And then it goes counterclockwise. Usually people want to go this way. Go counterclockwise. So 1, 2, 3, 4. You have your positives, negative positive, negative negative, positive negative. And you will need to know these for the Chapter 4 test. So go ahead and write this down. Hit play when you're ready. Now we're going to go on to Lesson 4.2. And this lesson involves a lot of vocabulary and just memorizing some rules and way that you determine things. So there isn't going to be much math involved. It relates directly to a lot of the math you're going to do this year, but there just isn't very much calculating. So you're going to really need to study this lesson and learn all the vocabulary and how to identify the different things before your Chapter 4 test. First thing we're going to talk about is what a relation is. And a relation is a set of ordered pairs. And ordered pairs are what we just talked about in Lesson 4.1, like an x, y. So I'll put that there. It's a set of these. Each of these relations has a domain and a range. The domain is always the x's, the x values, and the range is always the y values. You're going to need to know this the rest of the year because it comes up a lot. So one way that they show relations is using braces. So showing a relation using braces. And this is an example of a relation. Something like, there's a brace, and you're just going to have to practice them. A lot of people have trouble with them, but you'll get used to it. Just go out, little dip out, and back over. So we have the ordered pair 18, 4, commas between your ordered pairs, 16 and 4.5, 20 and 5.5. So that's an example of a relation, set of ordered pairs in braces. They're going to ask you to find the domain and the range of some of these braces. So all you do is look at your x values for your domains, your y values for your ranges. And you write them like this. So my domain is, and then you just write them in, 18, 16, 20. A lot of people end up putting those in order. Your range is, and you just go through your y's, 4, 4.5, 5.5. That's all you have to do when they ask for the domain and range of a relation. Now, there's a special type of relation, and this is what we're going to be dealing with for basically most of the rest of the year, and that is called a function. This is a special type of relation. definitely need to know about. So it's a special type of relation, which means that we can have relations that are not functions, and we can have relations that are functions. Every single function is a relation. It's a special type of relation. And this is what makes it special. For every value of x, there is only one y value to go with it. Okay, and you'll see more about that in a minute, of how that works. So let's go ahead and look at that. So one way to show relations is using the braces like this. Another way to show a relation is a mapping diagram. And you're going to have to know how to do this. And this is really nice to use when you're trying to find out if something is a function or not. So what you're going to do with a mapping diagram is you're going to put the domain on the left, range on the right, like that. Then you're going to draw an oval like that for each of them. And whatever they give you for the domain, they might give it to you in braces and ask you to write it as a mapping diagram. So we're going to go ahead and take these braces and write them in a mapping diagram. So we're going to write our domains into the domain. So we have 18, 16, and 20. And we're going to write our ranges into the range. 4, 4.5, 5.5. If you had a repeating number in one of those, don't put it in twice. Just leave it. Now you draw a line that goes from each domain that matches the range. So 18 to 4, 16 to 4.5, 20 to 5.5. 18 goes to 4. Let me go ahead and make that darker. 18 goes to 4, 16 goes to 4.5, 20 goes to 5.5. They're not always going to line up perfectly across like that, just did in this particular example. Now, the way that you determine if a relation that you're given is a function is you look to see, does every value of x that was given only have one value of y that it goes to? 18 goes to 4, nothing else. 16 goes to 4.5, nothing else. 20 goes to 5.5, nothing else. So that makes this a function. So this is a function. Okay, and the reason it's a function, over here you can put it in. X's don't repeat. But you just so you know, y's can. Okay, y's can repeat over and over and over, it doesn't matter. There are 4 main ways to determine if a relation is a function or not. We just went over 2 of them. One is just, the general rule is you're looking for repeating x's using one of these 3 things. But you can also look for your repeating x's just right here in your braces originally. But the other ways are the mapping diagram, which we just went over, a table, which we're going to go over next, and a vertical line test, which you use when you have a graph. So go ahead and write those down. When you're done writing those down, hit play again. I'm going to show you an example of something that ends up being a function and not a function, so you can see it in a mapping diagram. So first we're going to look at not a function. And then we're going to look at a function. Remember, I told you it's a lot of vocabulary. You're going to have to memorize all of this. So I'm going to give you a domain, and I'm just going to give these to you, of 4, 2, and -3. And then I'm going to give you a range of 3, -1, -3, 4. Now I'm going to give you a set of ordered pairs to match up. 4, 3, 2, -1, -3, -3, and 2, 4. So if I gave you this, you would write out your mapping diagram, put the domain, I have a 4, a 2, a -3, and a 2. 4, 2, -3, and remember I said don't repeat, so 2. Range was 3, -1, -3, and 4. Now you're going to draw your lines to match. So I go from 4 to 3, 2 to -1, -3 to -3, 2 to 4. This is not a function because I have a repeating x that goes to 2 y's. X's can't repeat. Only one y value to go with each x. So as soon as you see this right there, you know you don't have a function. You still have a relation, just not a function. Notice here, this is where I was talking about there, look for repeating x's. There's a repeating x. There's a 2 here and a 2 here, and they both have a different y that they go with. So that is not a function. Now I'm going to show you an example of one that is a function. Your domain is 4, 2, and -3. Your range is -3, -1. Your ordered pairs that go with it are 4, -3, 2, -3, -3, -1. So go ahead and draw a line from each one. So 4 to -3, 2 to -3, -3 to -1. This is a function. Notice that you have 2 x values that go to the same y. Y's can repeat. It's only x's that can't. So we can have 2 different domains going to the same range, just can't have this. So you need to memorize that difference. Go ahead and copy this down. Hit pause. When you're done copying it, hit play. So this example is showing exactly what we already did on the last set of examples. You're just looking again to compare x's and look for repeating values. And that tells you if something is a function or not. It's just another way of looking at it. So in this chart, they give us distance and time. Your distance right here is based on the time. And so you're looking at your domain and your range. And so this right here is your domain range. So these are all your x's, all your y's, you look for repeating x's. There are no repeating x's, so that means that this is a function. And you could write this way. 100, 10, 800, 107, 445, and 220. And then notice again, no repeating x's. So this is a function. That's what a lot of this lesson is going to be, is just looking to find out if things are functions or not. The last test you can use to determine if something is a function or not is the vertical line test. Vertical means up and down, just in case you forgot. The only time you're going to use this is when you already have a graph. So go ahead and copy this example down. I know these are probably hard to figure out, so I'm going to go ahead and write them below in braces. So we have the point -5, -2. We have the point -2, 1. We have the point 1, 1. We have the point 4, 0. And we have the point 4, 4. So, if you're already good at looking for repeating x's, hopefully you noticed we already have 2 repeating x's right here. But I'm going to show you how that relates in a vertical line test. So go ahead and make your graph, write down this with your braces, and then hit play when you're ready. What do you do with a vertical line test? You can basically use your pencil, but I'm going to show you with this card right here. The vertical line test, what you're doing is you're running across the graph and you're looking for a spot where vertically you connect 2 dots together. So right there, that makes this not a function. All of these are fine. They never connect 2 at a time. But that one point right there makes this not a function. The reason that works is because you end up at 4, 0, 4, 4, repeating x with a different y. You can have repeating y's. Notice if we were to do a horizontal line test, those are the same. Doesn't matter. We're not looking at that. We're looking at x's repeating, and there they repeat. So that's all you do with a vertical line test. Go ahead and write this down right here. It's just saying what I talked about, an imaginary line that crosses through more than one point. And on your notes, you might want to just grab like a lighter pen or pencil and just draw that imaginary line there that shows it crossing through those 2 points, so you remember later how that works. Hit play when you're ready to look at a couple more examples. Here's what we're going to do. I want you to take a blank piece of paper, the next page in your notes, unless you have a lot of room left on the page you're on, and I want you to write function on one side, not a function on the other side with a line down the middle. So do that right now. Now I'm going to put up a graph, and when I put up the graph, I want you to use the vertical line test we talked about to try to determine if it should go on the function side or the not a function side. And then once we decide which side it'll go on, you can draw it in on your paper. So here's the first one. So use the vertical line test and decide, is it going to go on this side or this side? Hopefully you decided it was going to go on this side, because if you notice, there's a bunch of repeating x values. It's crossing twice, a bunch of times. So that is not a function. Draw then on that on that side. And this will be any of these shapes. You could go ahead and add like a square or rectangle on there, triangle, any shape like that. You're going to end up crossing more than once at a time. So not functions. Hit pause if you're not done, otherwise we'll go on to the next one. Okay, so look at that. Determine if it is or is not a function. So should it go on this side or should it go on this side? And if you took a vertical line test and you went across, there's never a point where the blue line touches twice, so this is a function. This is actually called a linear function. If you want to write it down, it's all of chapter 5. And most of chapter 6 too. So go ahead and draw a small picture of that in on function. Let's try another one. So is this a function or is it not a function? This one's a little tricky because as you're going right here, this never actually fully straightens out, so it never crosses officially twice. You need a straight line for it to cross. That gets really close, but it never crosses twice. So that actually is a function. That should have been on this side. You just have to make sure this never goes straight. Even though it's starting to look like it, you have to imagine if we were to expand that graph. You might want to draw yours a little wider so you really see that difference. What happens when I do this then? Is it still a function? If you were to take this same graph and draw it that way, like an S, it is not a function because it's crossing even 1, 2, 3 places at some points. So not a function. So go ahead and draw both of those in. Draw one that looks like that on the function side, like that on the non-function side. There's a better example of the function one, where it's a little wider apart, so you can see it a little better. Okay, hit pause if you're not done, otherwise we're going to move on. What about this one? Function or not a function? Vertical line test. A bunch of repeating y's, but it never crosses x twice, so that is a function. Now do the same thing though. What happens if I do that? So now I have a vertical line. Vertical line says, yep, it's got a lot of repeating x's. Every single one of them. Not a function. So write that one in. And now move on to the next one. Again, hit pause if I'm moving too fast. And your picture doesn't have to be exactly the same, but get the part that you decide makes it either a function or not, and make sure that part's right. So if I took that, do I ever cross twice? Notice here I never cross twice, so at this point it's still a function. Function, even function there, because I'm not crossing twice, that's where it's no longer a function. So now it's not a function because of that straight line. Not because of the horizontal line, it's the vertical line. Draw something like that in there. And then let's look at the last one. Is this a function or not a function? Again, you go with that vertical line test. It never actually crosses twice. Right here it gets really, 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 really close, but it never does. So that is a function. It's like a u. It's called a parabola. These are quadratic functions, which you're going to be dealing with second semester. And then after you're done drawing that, let's talk about that for a second. Same idea. If that was to turn sideways, is it still a function? And right away you should have determined no, because we're crossing twice, 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 twice. It keeps going until it gets to that very end point there. So that is not a function. Go ahead and draw that in. Find your line that was a function that looked like that. And just make yourself a little note on it that this is repeating, y's. Because remember, you're allowed to repeat y's. And that's lesson 4 too. So make sure you learn all of this vocabulary very well this chapter.